Hi everyone, how are we doing? Almost lunchtime. It's not great to be the talk right before lunch, but my name is Christine. I'm a staff member here at ALCF, and I'm going to talk to you today about workflows at the facility, workflow tools, and I guess I'll just start by saying like, what is a workflow? What do I mean when I say a workflow tool? And in some sense, everyone has a workflow. I mean, you have some set of steps that you take, that you log onto our machine, that you take to get a scientific result. But what I mean when I'm going to talk about workflow tools in this talk is it's a piece of software that will orchestrate the execution of large numbers of tasks on compute resources, our compute resources here at ALCF, but on other machines as well. And why would you consider using a tool like this? I mean, you probably have seen in earlier sessions how you can write a bash script to submit work to PBS, our scheduler. But what can having a workflow tool do that for you? What can that provide? Well, it can allow you to run many tasks concurrently, and by many tasks, like we run some of the biggest machines here in the world, so we have users that want to run millions of tasks sometimes. So it allows you to run many tasks concurrently or asynchronously, however you want, across one or many batch jobs. Maybe you need many batch jobs to run all of your millions of tasks. It can allow you to manage task dependencies if there's some things that have to happen before other things. It can allow you to automate error handling. Say you have 1 million tasks and 1% of them fail. That's still a lot of tasks. That's more than a human can deal with, right? And it can allow you also to couple the execution of tasks to data movement, connecting back to Greg's talk with Globus transfers, for example. So ALCF and ANL have developed a lot of different tools, and we have partnerships with Globus Labs that have allowed us to use different tools. And this is a little figure from a paper where this group used a tool called Parcel, which I'll talk about, to execute a workflow for creating synthetic images for a telescope survey. So, as an example. So in today's talk, I'm going to cover some common workflow tools here at the facility, but of course there are many tools and I can't cover them all. So if there's something here that I don't discuss, but you're interested in discussing, I'd be happy to talk with you, or we have other staff that have expertise with a number of different tools. So I'm going to sort of do some demos like this. I'm going to hopefully show you some code and show you, log onto Polaris and show you how you can use some of these things. So I'll cover sort of 2 tools in depth, one called Balsam, and this is a tool that's been developed here at ALCF in the data science group. And this is a particularly good tool for deploying large ensembles of multi-node MPI jobs. So we have a lot of users doing, molecular dynamics runs, or, where they need to just simulate a bunch of compounds with VASP or LAMPS or something like that. This tool can also be used to execute tasks remotely, so I can talk a little bit about that as well. And then I'm going to do a demo on Parcel, which is a tool developed by Globus Labs, UChicago, and ANL. And this is a really good choice for deploying locally executed high throughput workflows. And I should say it's also sort of the foundation on which Globus Compute is built. So learning some things about Parcel will help you learn some things about Globus Compute. And if time permits, I'll talk about Globus Compute. And I will say there is in the repo a complete sort of exercise for Globus Compute, where it'll show you how to make an endpoint and run some functions and things. So those are some of the things I'll talk about. And like I said, again, if there's other things you want to discuss, we'd be happy to talk to you about that. Okay, so the first demo I'm gonna talk about is one with Balsam. And one note about Balsam is this is, it's a workflow tool, but it's also like a service we provide. So in order to be able to use Balsam on our machines, you need to be added to the Balsam server. So if you would like to test this out, you can either drop a message in the Slack channel or email our support, and we can add you. It takes a few seconds. It's really not a big deal. So I should say, why do you need the access to this service? And the reason is Balsam works on a database model. So your workflow tasks are contained within a database, and this database will track the status of the tasks, like they'll have different task states, and it will allow you to sort of query tasks and establish dependencies between tasks. It's based on Python, so there's a very, you can install it pretty easily with pip, and it has both a Python API and a command line tool. So you can work with it, you can write a Python script to work with it exclusively in Python, or you can work with it on the command line. It's really a popular choice at the facility for running large ensembles of multi-node MPI jobs. So if you see, can you see my cursor? Okay, great. Suppose you had a batch job on Polaris, say 200 nodes, on Aurora, maybe 2,000 nodes, and you want to just run an ensemble of a bunch of 1 node or 2 node or 10 node jobs, and you want to pack them all into that job. And you'll notice our queues are sort of designed in a way that we want you to run large jobs. You get more time the larger you make your job in terms of nodes. So in that kind of model, what you could use Balsam for is you can grab a big chunk of nodes and Balsam will just pack work into that job. And I will say, yes, so that's often what a lot of Balsam users use it for and why they use it. And I will say there is like I said, this centralized server that we will give you access to, and you can query that from anywhere. So you can also, in principle, drive your workflow from your laptop. You don't necessarily, there's some setup you have to do on the machine, but you can also query it from other places, and you can also have different, we'll talk about Balsam sites. You can have different Balsam sites running on different machines, for example, and working together. Okay. So how does Balsam define work and manage work? So the first thing you'll have to do when you run Balsam is you'll have to create a Balsam app. And the way we define that in Balsam is with a Python class. So you will have to write some Python code to start with. And this is like a little example. This is an application we're going to call lamps. And there's sort of 2 things you have to provide the site, and we'll talk about what that is. This is going to be basically the place where you're going to be running the work. This will be on Polaris, and it will stand up both a workspace for you on Polaris and a process that will query the database and run work for you. And then you also need to give it a command to run. And in this case, this is a code called lamps, which is a molecular dynamics code. And this is the executable. You can also add methods to this class that can do different things for you. So for example, you can run this shell preamble class, which will do some setup commands before your application runs. For example, you might want to set an environment variable in this case. And so once you register, and we'll see how this works, register an application with the Balsam site, you can use the command line tool to query, track, and execute jobs. And you can also, again, do it through Python as well. And so this is a little example showing you what that would look like. Okay, so how am I doing on time? We will sort of switch gears here. So this is a copy of, this is the repository for the conference. And if you go to the workflow section, you'll see a bunch of exercises set up for the different tools I'll talk about. So we're going to start with Balsam. I'll click on that. And you can see here a description of how to do this. And I will say there's a bunch of intro material. In the interest of time, I won't go through all of this, but you need to log into Polaris, you need to clone the repo. One thing I'll start with and say is that I did create a Python virtual environment with all the dependencies you need for all 3 exercises installed. So if I go to my shell, I've actually already activated it, but if you can look back in my history, you just basically will copy this command, source, and then this environment. Okay, so the next thing you will need to do is you'll need to log into Balsam. So if I do Balsam login, and this will basically establish your credentials with the server, and what it's going to tell me is that I'm already logged in, and it says here you already logged in, you have a good token stored. The tokens expire after a month. So I'm not going to log in myself, but if you do that, you'll be given a URL, you paste that in a browser, it'll take you to our authentication page, you put in your credentials. It's pretty simple. Okay, then the next thing you need to do is set up a site, and I kind of alluded to this before. This is essentially, it will be sort of two things. It's a workspace on the machine where results will be stored, and where you'll have sort of settings and different templates for jobs and things. And then it will also be a background process that will run on the login node of the machine, which will be talking to the Balsam server, and that's the way in which you interact with the Balsam service. So to create a site, and I have already done this in the interest of time, so I won't do it, but you would paste this command into your browser, and it will create a site for you called Polaris Tutorial. And it will bring up a little menu where you have to select your machine. So you should select Polaris because that's what you're running on. And then it will also prompt you for your project, your primary allocation, which will, for this case, will be ALCF training, which is the project that we're using for the conference. So once you do that, then you need to go to the site. You'll have a directory. So if I go to, I set it up here, and you can see here I have this directory, Polaris Tutorial. And you can see here that a bunch of things. There's a directory for logs. There's a directory called QSubmit, and that's where Balsam will store all the submission scripts it writes for you. And then a directory called data, which is where all the data of your tasks or your jobs will end up. And then there's some other things like the settings, which if you might need to touch for other, we won't do that in this demo, but and then it'll also give you, I've already activated my site. Once you do Balsam site start, it will then also store the process ID in the machine of where your Balsam service process is running. So I've already done Balsam site start. You would need to do that. And then actually you can see the status of your site if you do Balsam site LS, and I have a ton of sites, so it's a bit messy, but you can see down here I have Balsam Polaris Tutorial, and that is active. Yeah, it has a yes. So we're good to go. Okay. So the next thing you need to do is create an application, and this is the one thing that does require some Python. And we have here a little application for the demo called hello, and it will just execute an echo command. So it will just say hello and whatever you say hello to, and it will also report what environment variable it has set for CUDA visible devices. So for example, if you wanted to submit tasks to different, different GPUs on Polaris, you want your workflow tool to be able to set this for you. And so this would verify that. So I will just run this. Oh, I need to go up to where I have my scripts. So I have all the scripts for the demo here. So the first step, I will register my application. Okay, and then if I do Balsam app ls, so I list my applications, I can see I now have this application hello registered in site Polaris Tutorial. So now I can use this application and run it. And so the first sort of exercise here is to just use the command line tool to do this. And so you can create some jobs. You can create a job with the command line tool, and this is what this looks like. You do Balsam job create, and you give it your site, your application, things about the resources you want for this job to use, and we'll say, you know, we want it to run on 1 GPU. You need to give it a work directory. So where will the standard out of your application be stored? And that will be relative to the data directory that's in your site. So it'll create a directory within data called demo/hello. You have to give it parameter inputs. And you can also give it things like tags, which can be useful if you're like querying and running jobs. So I'll just run this script, which is script number 1. And so it will, well, first this script did Balsam app ls. So it again told me I have that application, and then it will show me that it created this job, and it has all of these data. And then it told me, it then queried the jobs that I have registered in my site as the last thing, and it said it was staged in, but if I do Balsam job ls, it should now tell me that my job is pre-processed, which means it's ready to run. So then I can submit this job through Balsam to the scheduler, and that's script number 2, where you'll see we're going to execute this command line command Balsam queue submit, where you're going to submit a batch job to PBS that will then query your Balsam database and run the work you have available in it. And so let's look at these parameters. The first is the number of nodes for the job that you're submitting, the batch job. T is the time in minutes that is going to be given the wall clock time. Q is going to be the queue. A is the project, and then you have to tell it the site that it's going to be pulling work from. If you want to restrict the work that it runs, if you only want it to run jobs with certain tags, you know, here we'll only run things that have a tag that's workflow hello. And then this last piece is important. This is job mode, MPI. So what this will do is it will take, for every job in your database, it will take whatever is in the command template and pass that to MPI. And it will construct an MPI exec call for that application that is consistent with the resources as defined when you created the job that will be consistent with that. So this should run this with MPI, and it will do it, you know, with 1 node, 1 rank per node, and all of these other settings. So I'm gonna run this. Let's see. This is script number 2. So it submitted a job. It should have submitted a job first to the Balsam, you know, service, which then should create a job on the scheduler on my behalf. So if I do qstat UC Simpson, I can see that, oh, I have a job running. And so this job was submitted for me by Balsam, if that makes sense. So then if I query my Balsam jobs, Balsam job ls, I can see that, oh, my job has finished. So now what's happened is Balsam has taken this hello job, it's run it in this batch job for me and updated the state in my database. And I can look at in my site, Polaris tutorial data, I now have this demo directory, which was the work dir, if you'll remember, for this job. And I have this Balsam log and Balsam job.out for this job. And so if I can cat that, Polaris tutorial data demo, you can see here, oh, it has the standard out of this job, and it says, hello world, which was the input parameter I passed it. And then Balsam essentially submitted this job and set for me a GPU to run it on. And so for this case, it ran it on GPU number 3. Well, I mean, it didn't run echo on the GPU, but you know what I'm saying. It set this GPU for this task for me. And so if I wanted to then just run this on, you know, say it was doing, instead of echo hello, like some matrix multiplication or something, it could run, you know, thousands of these on different GPUs for me, and I could just very simply create this work in this database. Okay, so this is showing you how to use the command line tool. But often if you're creating a large number of jobs, you probably want to be doing it with some Python scripts. So if you're creating, thousands or millions of jobs. So there is a Python API as well. So what you can do is you can create a Python script that might look something like this, where you can create basically a list of job objects, and for each job, you would have to give it a few things. You'd have to tell it the site that it's going to be attached to, the application it's going to run, and that application has to be registered in the site. You can set a work dir, and it could be unique for each one. So here, this will create jobs in these different, that will write their standard out to these different work dirs, which will be demo, hello, multi, 0, 1, 2, 3, 4. You would give it the parameters, any tags. This will tell this parameter here. So like before, we're going to be running this on one GPU, but now we're going to tell it, actually, you can run 4 of these jobs together on the same node. So this is called the node packing count. And then once you create these jobs, you have to register them with your site, which this job objects bulk create command will do for you. And let me just do that. So this is a Python script, so I have to run this with Python, and it should just return. Let's see. All right, and if I do Balsam job ls, I can see that I now have a bunch of, I guess this said 4 here, but it created 8 for me. So I guess the scripts and the README are not consistent, but it created a bunch of these hello jobs with this tag hello multi in my site, and they are pre-processed. So I could then spin up a batch job on the scheduler with that command line command again, or alternatively, you can also do that through before I go on to that, maybe I should just mention another thing you might want to do with the Python API is create dependencies between your jobs. And so this will be maybe the last thing I'll do here. We'll create a bunch of jobs with dependencies, and then we can run them all with this last script here, which will submit a batch job, but using the Python API here. So if I do Balsam job ls, you can see that I now have a bunch of jobs in my database. Some of them are ready to run, some are waiting for parent jobs to run. But if I do qstat q user C Simpson, you can see that I have a job running that will run all of these. So this gives you a little flavor of how you can use Balsam. There's a bunch of exercises in this demo where you can do things like, for example, create analytics plots, querying your jobs in your database to understand how they ran. And then in the end here, this is a more realistic example that shows you how to run something wrapping around a compiled executable hello affinity. This is taken from our getting started repo, and there's a compiled version of that hello affinity application in the workflows directory. So this gives you a little taste of what it looks like to use a database workflow tool. So you basically, like you saw, you have this database, you can query it, you can track work, etc. Okay, now I'm going to move on to Parcel. So Parcel is a different workflow tool. This is developed at U Chicago with Globus Labs, and this does not work on a database model. So instead, with Parcel, your entire workflow is contained within memory. So you don't have to deal with a database, which can be a good thing or a bad thing, depending on what you want or need. And Parcel, again, is based in Python. So you can install it with pip. You can use it to, similarly, you have to define applications to run with Parcel, but instead of classes, they're defined as functions. So you can create what's called a Python app, which will run a native Python function, or you can create a Bash app that will wrap around a compiled executable. You can, the one thing to note is that the configuration, you have to provide that yourself. So you have to create what's called a config object, and I'll show you what that looks like, where you have to tell it how to submit to the scheduler, how to divide tasks between resources, et cetera. And then the one other thing that might be important to know is that this is built on top of Python's concurrent futures model. And this, it takes a little time to wrap your head around, but essentially, rather than your applications returning directly the results that they produce, they return what's called a futures object, which is a proxy for the result, which may or may not have been fulfilled yet. So essentially, your workflow will create these futures, and then you give it a configuration that tells Parcel how to fulfill those futures, and then that happens in the background. You don't necessarily see that, but then you query that. You can query that later. And just to give you a little example of what that looks like, you have to program with that in mind. So for example, here, you might have an application that just multiplies a number by 2. So in order to run these tasks through Parcel, you will call this Python app double. You might give it 2 different inputs, and then it will create these 2 different objects, D1 and D2, but these don't return 6 and 10. What they return is the future that you can then query the result of this way, which will then print those to the command line. So essentially, you have to create these futures, and then somewhere in the code, you do have to query those futures. Otherwise, your script will return without, giving you the results, if that makes sense. So another way to point out is if you want to create dependencies between tasks, say you have, again, that function double, and now you have a different function square, and you want to create a dependency between a task that runs double and a task that runs square, what you need to do is you need to pass the result to square, because square can't run until double has completed, right? So you have to pass, you need to pass not just the future, you need to pass the condition under which the future is fulfilled, so the result, if that makes sense. Okay, so let's go on to the demo, and I will go back here.
Christine?
Yep.
I just wanted to make the observation that for those people who are familiar with MPI, this is directly analogous to an MPI request, right? You do an ISIN, then you do a wait or a stat. Anyway.
Yeah, no, that's a great observation, Ray. Thank you. Okay, so let's move to the Parcel demo. So again, there are some exercises here. So the first one we'll just start with is the very simple one from the first slide, where you just have 2 applications, both running hello. One is the Python version, where it will just return the string. And then the other one wraps around well, in this case, it's not a compiled executable, it's a echo command, but a command line command, essentially. And what you need to do to call this is you first need to do this Parcel load command. And so this is essentially, we'll just elide over this for now, but this is telling Parcel how to execute work. Right now, we're just using the default config, which executes tasks on local threads. So these tasks will run actually on the login node, on threads on the login node, but there's just two things, so it should be fine. And to invoke them, you need to create them, and then you need to call the result, right? And we'll do this for both. One thing to point out for Parcel, if you want to sort of create dependencies between apps, it's very simple to do with Python apps. But for the Bash apps, you can't pass the results through memory. Essentially, the result will return you the return code of the application. So instead, you need to print the results to a file on the file system that you then query if you want to, pass some result from standard out of that compiled application to the next app, for example. So I will just run this getting started. And so this will run pretty quickly. And it reported hello world Python, hello world Bash. And if I look, I have this hello standard out, which contained the standard out of my Bash app. Okay, so in here are a bunch of exercises showing you examples of how to run different patterns. So there's one where you can run a bunch of applications or tasks in parallel. There's one where it will show you how to chain them together in a sequential flow. And then this is using what's called a join app, which is a slightly different kind of app, which will combine results from multiple applications. So if you have, you want to combine the results of multiple applications into one application, this could be a pattern that you would be interested in working with. Okay, so we were just running tasks on the login node. What we want to do, though, is run on the compute nodes. So what we need to do is, rather than loading the default config, we need to load a config for executing work on Polaris compute nodes. And there's a bunch of description in here telling you the details of all these different things, but this is what a config could look like for a Parcel workflow on Polaris. Now, exactly what yours would look like for your case or your application would depend on your needs and what your tasks are doing. So I'm not saying this is what you have to do for Polaris. This is an example, but depending on how you're using the hardware, et cetera, yours might look different. So this is just designed for this case. So I'll just go through, highlight a few details of this. So we have to create a config object. So you need to import the config class here. And what you then need to do is provide an executor. So this is what will run tasks. And in this case, we're going to use something called the high throughput executor, which is a good choice often for high performance computing. And then what you need to do is you need to tell the executor how it will provide resources and how it will, assign workers to your resources. So the two parameters here I'll highlight. One is max workers per node. So what this is going to do is it's going to stand up workers on different nodes, and you need to tell it how many workers you'll have per node. And then in this case, we want to use the GPUs on Polaris. So this is necessary to tell Parcel that you want your workers to be assigned to one per GPU. So we're going to do 4 workers per node, 1 per GPU on a Polaris node. A Polaris node has 4 NVIDIA A100s. Then you need to tell it how to divide the CPUs amongst these workers. And this might look a little, here we go, a little complicated, but if you're familiar with MPI, this might be very familiar to you. So you essentially just tell it for each worker, if the workers are pinned to the CUDA devices 0, 1, 2, 3, that these range of hardware threads separated by colons will be assigned to those GPUs. The The next thing and I'm not going to explain everything in detail in this config, but I'm happy to talk to you about it later. The next is you need to give it the provider. How is it going to provide these resources? It will provide it through PBS, the scheduler on Polaris. So you give it provider PBS. This is where all the kinds of things that would appear in your submit script would be. So the project, ALCF training, the queue. This is worker init. This is very important. This is where you can provide commands that will execute before your workers start. And you absolutely have to activate an environment that has Parcel installed. If you don't do that, then things will fail. So that is necessary, but then you can also add additional things if you want to set environment variables, load modules, things like that. That's where this would go. You need to give it a wall time. And then there might be additional things you need to provide to PBS on Polaris. One of those things is the file systems. You have to tell it what file systems it will have, the job will have access to. And you need to give, I'll come back to the launcher in a second, but you need to then tell it how many nodes per block. You can think of the block as the job, essentially. So how many nodes are going to be in the jobs you create that will run your Parcel apps or your Parcel tasks, and then how many blocks you allow to exist. So you can actually, divide up your work amongst many or just a few. And then the last thing I will touch on is how do you launch the workers? And in this case, we're going to be using MPI to launch the workers. Now, we're not using MPI to do message passing or anything. So we're just using it in this case as a parallel launcher. So it will just run an instance of the Parcel worker process on each rank that you give it. Okay, so then if you want to run any of the examples I just showed you before with this config, all you would do is something like this, where you from config import Polaris config, and then you just replace this Parcel load Polaris config. So this is an important point about Parcel, is that the definition of your workflow and the definition of the configuration of how your workflow stands up workers, they are separable, right? So you could write a workflow and then have configs for different machines, and you can just run them like that. So in this case, I have this example, Hello Affinity, and I will just start this going, and maybe it will finish, but essentially all it's doing is it's running this bash app that again wraps around this application Hello Affinity. So it will basically have every worker tell me what resources it's pinned to. And then, and here it is. So here it then printed the standard out from all these tasks, and you can see maybe that all the GPUs are unique. So they all ran on individual GPUs. And then you can also see that the threads, the list of CPU cores, were different for each GPU as well, according to what I set in my config. So if you ever want to test whether your Parcel config is doing what you intend, you create a Hello Affinity app that runs this application that you can find in our Getting Started repo. That's a good way to check. Okay, so the last thing I'll touch on with Parcel, and I'm running out of time, is support for MPI apps. And this is something that Parcel has implemented in the past year. So this is a relatively new feature. So I've provided an example for how to run essentially that Hello Affinity application, but running it on multiple nodes and multiple ranks per node with MPI. And so you need a different configuration. And so you might say, well, wait a minute, you were using MPI in the last example, but I was using MPI as a launcher for independent workers. In this case, what I'm going to be doing is using MPI as the executor for each individual task. So each task will be perhaps an application that involves MPI communication. So you need to launch each individual task is an MPI exec call. And then your launcher is what's something called a simple launcher. And so your config looks different. So you still have the same provider, but instead you have the MPI executor with the simple launcher. And the thing that you should understand is you need to make sure that your max workers per block is consistent with how many nodes you have in your block and how many nodes each application instance needs. And so when you write your app looks different. You again will write a bash app, but you need to pass to it a parameter called parcel resource specification, which is a dictionary that provides the information it needs to construct the MPI exec call, essentially. So the number of nodes, the ranks per nodes, the number of ranks. And essentially then parcel automatically will set in the background this parcel MPI prefix environment variable. And so then what you return as the application will be that environment variable. Any additional MPI exec options you need to provide, maybe a CPU bind option, and then the call to your application. And so this will, and then the rest of it looks very similar. You create tasks in the same way, you run them in the same way. So the last thing I will say is the way I've shown you how to run Parcel, these scripts won't return until the futures are fulfilled. And if you're running a multi-hour job, that could be a problem. You don't want to keep a shell open on a login node. So often what people do with Parcel is they create a screen session, and there's some instructions here for how to do that. So you can create a screen session and you can launch that, launch your work within that session, and then you can detach from that session and reattach when you want to go back and check things later. There is also a way to configure Parcel to run entirely within a batch job, and I can show you that, but sometimes what people want to do is run many tasks over many batch jobs, and in that case, you would need to do it the way I've shown you. So, okay, I've completely run out of time. So I'll just briefly mention, there's also a set of exercises for Globus Compute in that demo repo I provided, and you can take a look at that. Some of it will look very familiar to the Parcel demo. So some of the configuration is very similar. The way you work with futures is similar. So take a look at that. And yeah, I've run out of time, so I'll just end here. There's some additional resources and documentation and things, and I'm happy to talk to you. I'll be around for the rest of the day. So thank you.
Thanks a lot, Christine. That's a great talk, very informative.